You guys are going to be expert on EPDs and embodied carbon and carbon budget. By the end of the night, we're moving quite along ahead of schedule. Claire Nowasell, my previous job is technical service on the cement side. Title is project level carbon budget, but I really want to share what we have been learning along with our customers, which is our ready-mix producers this past year, and what our journey so far. All right, agenda. Let's get structure. Some motivations, which previous presenters already covered, and review some of the progress that we made on the material side, and want to really discuss what sustainability lives in the specification. A lot of producers, I'm not sure how many in the audience here, but they really focusing on the division 3. But there are other places that sustainability is declared for the project. And lastly is carbon budget. I feel like our topic has been pretty accommodating to each other, which is very cool. So on the motivation, the main drivers are on the legislation side. And here is a map on embodied carbon policy developed across North America. Not up to date. Maryland is not on here. But I think the whole idea is we see them developing across North America, across different legislation bodies, from as low as a city council to the most recent is the federal IRA, FHWA, and last year GSA also come out with the LEC, which is low embodied carbon specification, cover not only cement, concrete, also glass and steel, etc. So the general trend is driving the embodied carbon on materials, and specifically cement and concrete, because we are on the system boundary condition, we're much easier to target, and that's one of the reasons we are the first under the spotlight. Again, Stephanie already talked a lot about on this, and this is just an overview. We're not going to hop on this. Green building standards, not from the legislation side. A lot of the green building standards and specific the schemes such as LEED, Green Globe, Envision, Living Future, we're starting to see is originated in UK, but we're starting to see a lot of a project that following Living Future standard as well. You can see EPD is often mandatory, especially the version 5 for LEED is going to have a huge impact. And we remember when LEED first came out, it really drove the operational carbon change. What they have done for changing that landscape, I think the general consensus is version V5 will really drive the embodied carbon movement. And thank you for really getting into the nitty-gritty of version 5. Yeah. To soft plot on our cement PCA roadmap, for those that you are not familiar, I really like those 5 C's. So quickly review our PCA roadmap for carbon neutrality is focusing on from the clinker, reducing on clinker content in the cement, and on the cement, use less cement in your concrete. Concrete is, on that portion is, really think about optimizing your structural element, and use less concrete as a volume, and then really stretching out to construction and carbonation. I want to talk a little bit about carbonation. We really haven't, as an industry, focusing on that for concrete as a CO2 sink. I really think if you sit through some of the wood industry presentations, they really take advantage of the carbon cycle to promoting their product. I think as industry, we really should pay a little bit of attention and get really quantifying on the carbonation, and that will do us good as industry for pay attention to that aspect. All right. Our progress so far. Want to emphasizing on cement. I got this fresh off the press data from Jamie, PCA. Want to emphasize more than 63% of all cement consumed in U.S. are now considered low carbon cement, which primarily are blended cement. So that's improvement year over year. And on the concrete, we are in an EPD session, so quickly review. I'm not sure the data is quite accurate. I got this from the EC3 website. As of October 2024, there are 80,000 concrete EPDs in North America and 82,000 globally. So as a country, as a continent, we're ahead of the game on EPDs. As a international companies, I can say that yes, a lot of colleagues are kind of leaning on us on where the EPD and how that process. So we are doing pretty good on that. Quickly review. You can see the huge take from transitioning blended cement starting 2022. This is where the 63% of blended cement being used as a share of a total cement used in U.S. Also want to mention the 97% of the blended cement are 1L. So that's still the majority shift. If I can look into my crystal ball, the next shift is going to be type 1T, but we'll lean on our experience with 1L transition and hopefully learn from that and be good at that transition when it comes. Okay, so CO2 emission from concrete. So if you have submittals or Excel tables on what a mix design is, convert that into a pie chart, and this is what it look like, and it's no surprise, right? This is a mix design: 3 shovels of stone, 2 shovels of sand, and 1 shovel of cement, and then you got yourself a mix design. And no matter how you optimize it, they never really square away from those components. Majority is 72% on average are aggregate. Pay attention to the pink or orange on this. That's representing the cement. So converting that pile, a yard of concrete, into a EPD, into a pie chart, the story reverse. As you can see, the orange portion, the 10%, when it converted to concrete EPDs is 83% in this case. I do want to make, you can't see the cursor. It is EPD, concrete EPD, it is related to the functional unit of concrete. So do pay attention. Here is about 4,500 PSI concrete. I'm not sure if it's area trained or non-area trained. Just pay attention, cement is the lion's share of the embodied carbon just because the process of, we taking the kiln up to 2,600 Fahrenheit. It is a highly intensive energy process of making a product versus aggregate, right? It's coming out of quarry, you make big rock to small rock and wash it and ship it. There's really any thermal treatment into that process. So naturally, even though it's 72% by volume, it's really low embodied carbon in that sense. So those type of material characteristic really should be back of your head, and when you do a lot of this different top 10 ways to reduce your embodied carbon is from that thought process. Again, this is A1 to A3, so it does cover transportation and production, et cetera, et cetera. So through my travels, and a lot of producers challenge me, Claire, we're converting all my trucks to electrical EV, the next new things, right? Great, if you have that, great. But just pay attention, transportation in this case is this pink over here is only 4%, right? You got to the middle of nowhere ready mix, a huge yard, they want to put up a solar panel. Again, you're tackling the production, which is purple, 2%. So the low-hanging fruit really is the cement portion, and that's kind of the driving of the 1L transition and the any transition that going in the future. So that's kind of the reason, low-hanging fruit. briefly touched on comparing EPDs, and I do want to point on the caution on that. We talk a lot of producers, or not producers, project engineers, designers, and even owners rep. They oftentimes say, I've seen this EPDs, it got a 150, come on, look at it, can you produce it? So there is a cautionary notes on the comparability of EPDs. It's not always apple to apple or apple to applesauce. So do pay attention. EPD have a different, for concrete EPD, have a different functional unit. Primarily, you need to pay attention. If it's the same for the structural element, and particular to the exposure condition. Not all the producer will put their durability class on their EPDs. Most producer we've seen that will put area trained and non-area trained on their EPDs just to differentiate. Again, then maturity. Some of the low EPDs, they take it out to 90 days or 120 days on that. So that's a functional unit you need to pay attention to. Another thing is transportation is often ignored, right? You can have a producer A that's have a low GWP on their mix because all their raw materials are very close, and that story cannot be, or that process cannot be replaced to a producer that don't have that advantage, and vice versa. So those are reflected on the EPDs where you source your material. It is critical to gate. Just pay attention. You cannot always compare EPD that way. So when you do have a project that requires a certain level, those could be your talking point if you ever needed it. Again, I think similar, there's a lot of guide out there on how to general strategies for reducing carbon intensities for concrete mixtures. I think the general consensus, everybody has to get in the room and get in the room early. Have a clear goal. The owner and designers, and the contractors, and the concrete suppliers, and the testing agencies have to get together and have this reiterated process. And it has to be different stages, right? They have to get together, have a clear goal, and have a clear path to the head has to be in the same place to make a successful low carbon concrete project. Where does sustainability language belong? This is learning learning lesson for us too. Not just only in the concrete submittal. You are a concrete producer. Oftentimes you got O3, cast in place, and you read that. There are sustainability language in the whole specification as well. And Division 1 is really creating sustainable design requirement on this titles. And on the construction side, it also talk about construction waste management and disposals. So this really, on the technical section, providing support for specifying specific project. And here is an example. So Division 1, general requirement, it really kind of spell it out, the specific, the requirement, the standard, and definition. Example for VOCs, they want green guard, or EPD, what type of EPD? And right here, it kind of spell it out, a product specific EPD or industrial average EPD, and the reference for it. And regional materials, how many miles considered regional in this specification? Along that 01 general requirement, there's action plans, there's a progress report, and there's a closing out. So here's an example on action 1, which correlated to EPD portion is life cycle assessment, and just talk about where in that realm of life cycle assessment, which is EPD, and also we got asked a lot of corporate sustainability report. So that's also part of the story. And here is sustainable material cover sheet, where we find might be a good place for the carbon budget cover letter is sustainable material cover sheet. And with that, we'll transition. And here is embodied carbon LCA action plan. It's kind of tell you what the project's looking for. So here is an example of the cover sheet. They want a lead cover sheet for each material, and that's EPDs for fly ash, Portland cement, slag, silt reinforcement, and embodied carbon reduction report with a baseline and optimized product reduction, which I think is perfect place for RMCA's carbon budget report or a project level carbon reduction report. And then this is, you guys are really familiar because we're concrete folks here, Division 3, 330, typically cast in place concrete. And you will occasionally starting to see a lot of designers have a really high goals, and they throw everything on the table, the whole kitchen sink of tools, and they may be mistakenly using contractual language such as shell. So those are the things that will have a really clear goal. For example, right here, the first one, cementitious materials using fly ash, pozzolan, slag cement is needed to reduce the total amount of Portland cement which would otherwise be used by no less than 40%. And that can scare certain regions and certain market and for certain element. I mean, think about 40% for flat work, that can be scary. This is another example. They literally spell it out, all the tools, the top 10 ways to reducing carbon, and the highlight portion is carbon dioxide mineralization. I mean, those are tools not every producer will have that, and not everybody can afford to bring that on their site for a specific project. We found have a cover letter and have a project carbon budget reduction report has success to showcase the ready-mix producer knows what embodied carbon is and knows and already using a lot of the reduction levers such as SEMs, such as you can provide your standard deviation. Those are the part of the story that can show the project and could be part of the reduction story as well, can get away from those prescriptive, at least 40% SEM replacement or the need of using carbon mineralization for this specific project. So here's an example that we were able to overwrite that specification and get approved without using carbon dioxide mineralization in this case. So it's very simple. This is a previous version. It doesn't really refer to against the benchmark. I think the RMC newer one also kind of push you in. You have a drop-down table to look at how the proposed mix compared to GSA standards or RMC regional benchmark. This was pretty archaic before they changed. So what is the concrete carbon budget? There's quite a bit of tools there, but using RMCAs, they're the best. So the thought process are all the same, is total product GWT reduction. You have to know your baseline, and depends on the project. Sometimes they don't know the baseline, and in the project early on discussion, where oftentimes being stuck is, well, where to draw the sand, the mark in the sand, right? I think that's where the ACI 323 low carbon code going to be really useful for that. So if you can get over where your bench line is, and then you can kind of use your proposed mix design and their associated EPDs and the GWP on there to tabulate how much yard for that mix, and then just aggregate together and have a reduction from the bench yard to your project. And that's kind of what carbon project budget means. Why do we do that? Not concrete are created equal, right? Not all concrete elements have the opportunity or the room for you to reduce cement with SEMs. So we're looking at the whole project level is have the flexibility of pick and choose where elements have the most opportunity, etc. So as a cement producer, as a material producer, we educate the whole value chain. So what are we telling the stories out there is consider performance-based specification. That's always a good start. So you are no longer hell-bent on the minimal cement content or cement ratio, and using material efficiently. This is not being recorded, right? We're not getting hurt if you use less cement or less concrete. Just use enough for durability, for the mechanical, for the safety of your project. Don't overuse. And those are where the third-party testing lab come in place, because a lot of time over-design is trying to compensating the poor testing practice in the field. And using blended cement, maximize using SEMs where it's available, or alternative SEMs, or blended SEMs. Maximum recycled content for your reinforcement. Adjusting testing aids. I can recall a story when we communicating a dam engineer, and they often have the question when we bring up maturity, and they said, I've never thought about that. And I'm always surprised every time I get test report, 7,000 PSI in 7 days. Man, I don't need that PSI. I'm not going to put any load on there in 6 months, only for 5,000 PSI. So those are the things that producers overcompensating, that could be related to pay factor or, scheduling. But I think those are, a maturity is another way, a leverage for us to utilizing and gradually reducing our clinker content and reducing our cement content and increase the SEM. Again, the play with the matrix using aggregate optimization gradations, that's where it gives you less voice content and use less cement or cementitious. And using the state-of-the-art chemical admixtures to help you achieve that, right? This is just final examples on how to converting GWP target to a carbon budget. I'm sorry, the font is a little small, but generally is on the first column. It says applications, so tell you the concrete element, footings and floors or slabs and columns, exterior concrete. The second column is the design strength. 2,500 to 5,000. Exposure class is also can be an influence on the wall cement ratio and strength. And oftentimes we'll see a maximum GWP capped for that strength class. What we mean by a project level carbon budget is you look at the bed, right? You need 500 yards for the footings and 600 yards for the columns. So you tabulate all that volumes with a maximum GWP, and that's in total, in this case, for example, is 754,600 kilograms CO2 equivalent for that project. So we do encourage to enforce that as a whole, but we really don't like to enforce the individual mix level. For example, elevated deck or slabs, they may not have a lot of opportunities due to scheduling or due to finishing to replace cement content or increase SEMs. But places like columns, it may have a lot of opportunities, or foundations for providing a lower carbon concrete. Another thing we think could really benefit us as an industry is while you add another column for bonus maximum GWP for producers to have something to be incentivized, right? If you put another silos in, 1 or 2, if you bring in a novel materials, that's going to pose a premium, right? Nobody never talk about that. But I think if we can get together and have a consensus on bonus and maximum GWP, which is creating that benchmark for them to chase the lower GWP, and they may need to really tighten up their quality control, reduce their total powder content, then that's a cost to the producer, and that should be incentivized. So if for any specifier in the room, please incentivize us for the innovators in the industry. Here is an example. We can use that because we did that a case study. This is straight out of the Canadian report on how to do a low carbon concrete, successfully implementing low carbon concrete. This is a school that we did ready mix business have done in Vancouver, BC. It's a school. Here is the steps. So calculating concrete, first you need to know baseline. You may have a preliminary, you may have a final. Remember we talk about you may have to not use all the concrete efficiently. So you have a first step and calculate anticipated CO2 baseline, and then you take a look at all the concrete that you may use and may not use or can thin out the section, then you come up with another baseline for the final goal of the project. And then the scope 3 is for your ready mix producer that's providing their mix and plug it in the volume and have as built or a project level carbon budget. So in this case, the baseline final for the project was allocated for 813.1 ton of CO2. As built, the impact was 657. So we have a total reduction nearly 20%. It's 19.1. So that's kind of the workflow when we talk about carbon budget and how that look like. It's quite simple. It's simple math. But imagine you will have a pie chart for your cover letter. As part of your bid, I think it really tells a story, the cohesive, like a snapshot, how you are doing on the GWP. It really send a clear message to the project. And that is it. Any questions?